Welcome, nated student. We are looking at another question paper. This is another N1 question paper number 16030121. It was written on the 28th of July 2023. It was an X paper for 3 hours. And what we have is the following. Let me just try to go down. It's worth 100 marks. Instructions are provided as one would know. And in question 1 they say, I'm sorry that I'm not going to read the instructions that needs to be followed. Right, you always know that we need to draw up a line in order to save paper. Right, they say in question 1, simplify the following without the use of a calculator by using exponential laws. This is not for the first time we come across a question like this or an instruction of this nature. So we have a minus 2, b3, a3, b4, a3, b minus 2, 3. So this is what we come across. And what we can do here is the following. When you multiply, you add. Okay, minus 2 plus 3 is 1. When you multiply the same bases, you add 3 plus 4, 7. This 3 multiplies every exponent of the base, so you write your base. 3 times 3 is 9, you write your base. Negative 2 times 3 is minus 6. Very good. And then from here you have 1a. You have 9 of them. If you cancel 1, you'll be left with 8 on the denominator. There's 7, b7. When this goes on top, it becomes positive. And remember, on the denominator you would be left with 8 because you cancelled 1. Right, and then from here you would have b. This should give you 7, 8, 9, 10, 11, 12, 13 all over a8. Or somebody might want to write this as b13a minus 8. It's still fine. Whichever way you prefer, we are very much fine with that. Right, let us try to continue in this and see how far we can go. Right, that was worth 4 marks. 4 marks were provided for all this. Now let's go to 1.2. Solve for x. We have log subscript 4, x equals 3. We converting log to exponential. 4, 3 equals x. We have dealt with this even in n2, and then you just find the value of x there. I'm not going to complete that for you. Right, and then from there in 1.3, indicate whether the following statements are true or false, writing only true or false next to the question number. 1.3.1 till 8 in the answer book. So in 1.3.1 we have the log x y3. They say this is equals to log x minus 3 log 1. Let's check this. Right, I know when I divide I subtract. The subtraction is very true, so meaning this is log x minus log y3. Okay, we bring this 3 to the front, log 1, and this is exactly that, so this is true. And then we go to, let me just do this, 1.3.2. and there we have log subscript a, and a. Remember what we would do here, take this to the side, a log a, this is 1 times a is a. And do they have an answer of a there? No, they don't have it. What they have is this as the final answer, and this is never the final answer, because when you take this to the other side, this is 1 times a is a, so their answer is false. Right, 1.3.3, they say log a log b, they are saying this is equals to log a minus log b. Now let us try to check something here. This can be very much misleading. Why? Because the definition says the log of a over b, only this would be equals to log a minus log b. So you must have one base, and this you cannot reverse this to be that. That's not what it is. So these two things are totally different things. They are honestly very, very different. But let us we can argue on this, because somebody might say, okay, somebody might say, okay, this would be the same as log 10a log 10b, because the subscript is not written there. We would know that it's 10. And then from here somebody might say, all right, I have log this, and I can therefore say a divided by b. But we will just check. So when we check this, it's not the same as that. This is not this. Please, this is not equals to that. This is not equals to that. You must have the log, then you must have a divided by b. Only it is equals to that. So this is false. This is very much false. Please be very careful there. 1.3.4, we have log xa, and they are saying this is equals to a log this. They say this is the answer. Now let us check. If I take this to the other side, that is a log, I know if it is not written there, the subscript is 10 and x, so this is true. You should always know that when there is no number written there, the subscript is always 10. Now let's go to 1.3.5. we have x log y plus 3x log y, and they are saying that this is equals to log y to the exponent of 4x. Let us check whether this is true. I know when I add, I multiply. So what I'm going to do, I'm going to rewrite this and this. So this was log y exponent x. Before it was brought down, it was an exponent. Log y, before it was brought down, it was an exponent. Very good. Now I know that when I multiply, I add. So I'm going to say log, and when I multiply, I add. So I'm going to say yx times y3x. Can you see that? So I'm taking out a log and I'm saying when I add, I multiply. So you're saying yx multiplied by y to the exponent of 3. And you should know that when you multiply, you must be able to add the exponents. So let me just do it right here. so that we can have log, and then here when I multiply I add. X plus x is 4x. And do they have that? Log y 4x. Yes, this is exactly the same as that. So 1.3.5 is true also. I think this is very clear to you guys. And then we go to 1.3.6. we have x 2a minus 3 equals 1 over x3 minus 2a. They say this is equals to that, and we want to check if this is very true. So the best of what I can do here, now let's check what is happening here. A is positive, 2a is positive, this is negative, but there it's the opposite. This one is negative and that one is positive. So let me take this and take it to the top and see what would happen. So before I can do that, let me show you something. I can rewrite this as x3 times x minus 2, so that when I multiply I add. Can you see that? From there I can proceed and say, alright, let me take this one to the top, it would be x minus 3. Let me take this to the top, it would be x plus 2a. Can you see that? Very, very important, because the exponent changes the sign. Right, so what is this? When I multiply I add. This would be x 2a minus 3. Is this the same as that? Yes, therefore this is true. Something worthy of noting. You just have to know and understand the laws. So let's go to 1.3.7. so we have x plus y squared. They say this is equals to x squared plus y squared. Everybody would know that this is not true. Let's check. I'm going to repeat this 2 times. X squared plus xy plus xy, that is 2xy plus y squared. So can you see that this is not the same as this? So this is false. And then let me go to 1.3.8. So in 1.3.8 we have x squared plus y squared to exponent 0. The answer is 1. Yes, because they are all inside of the bracket raised to exponent 0, your answer will always and always be 1. So this is true. 1.3.9, they say that the ln of e is equals to 1. Yes, this is true. The ln of e is 1 by definition. Right, and then they say the log of a plus b is equals to log a plus log b. No, when you add, you multiply. This is equals to log a times log b. So what they are saying there is false. Right, let's go to question 2. And in 2.1 we have the following. Remove the brackets and simplify. Minus 3x, x plus 2, and they place a 4 there. Remember, there's multiplication also there. So what you need to do is just to say minus 3x times 4, that's minus 12x. You have your x plus 2. Very good. Let's multiply minus 12x squared minus 24x. Are we fine? Minus 12x squared minus 24x, and you are done. Right, and then we go to question 3. Right, in question 3, what is it that they want? Factorize the following expressions completely. They say x squared y 3, 7xy 3, 3. Okay, I want to factorize this completely. That is fine. Now before I can factorize, I can take out an LCD here, which is 3, and I can have x squared y plus 7xy 3, and there's a common factor here, which is 1x and 1y, so that I can say x plus 7y squared over 3. Let's check. This into this is x squared y. We will have 7xy 3, right, divided by 3, and there's nothing that I can do here, so this just remains the way in which it is, and 3 marks are provided for this. Somebody with a memorandum will just go and verify for us, but that's exactly what one should do then, right? And then once that is done, we can go to 3.1.2. Remember, we are still factorizing. 4x3 plus x squared plus 2 into 8x plus 2. So I want to factorize this. Alright, before I can factorize this, let me check what I can do here. I want to show you something, because even if I can remove the brackets here, it's not going to help me with anything, but I can sense something here. Now look what is happening here. Even if you take out a common factor here, you'll never be able to create that bracket. But let's remove the brackets and see. This is what we have. So this is a cubic function. We need to find the factor that makes this be equals to 0. So that's where the trial and error method now comes in. So what I'm going to do there, I'm going to look for a certain number. I'm going to start first with minus 1. With minus 1 to the exponent of 3 plus 1 squared plus 16 into minus 1 plus 4, and I get minus 15. So what if I use positive 1? Would never do it. Let's try with minus 2. Only a negative number can do this. Let me try with let me see. Yes, let me try with minus 2. Let me start with minus 2. Let me check with minus 2. Minus 2 doesn't work. What number can I use? Let me for the last time try with minus 3. Not having a calculator sometimes can be delaying. No, it seems not to be working. Alright, but then let's look at something. Right, let me look at something here. If you look in here, because with a positive number this would never give you 0. There has to be a negative number that works in here. But the more negative numbers I try, the more bigger number that I find. That's where the problem is. Let me try with minus 0.5. Let me try with 0.5. Let me try with 0.5. 0.5. Oh, guys, nothing seems to be working. And there has to be something that works here. There honestly has to be a number. Unfortunately, I wish I had a calculator so that I can punch in the numbers very quickly in such a way that I can do what I want to do quicker. Right, let me just pause this and try this on my own. All right, let's do this, because if we factorize here, I don't think there's something that can work here. But let's check something in here. If we take out x squared, we would have 4x plus 1, and if we take out 4 here, we would have 4x plus 1. There we go. Take out the common factor there, which is x squared. You have your 4x, so that when you multiply you get that, when you multiply you get this, plus you can take out the common factor of 4. 4 times 4 is 16x plus 1. Now we have something common here and there, which is 4x plus 1. We have x squared plus 4, and this is never a difference of 2 squares. I wonder why so many marks for this. 5 marks for something that didn't even take me 5 steps. Let me check whether I did things correctly here. 16x plus 4, there it is. There's something common here, which is x squared. You will have your 4x plus 1, very correct. 4x plus 1, very correct also. And then there's something common here and there, which is 4x plus 1, and you will have your x squared plus 4. Unfortunately, this is exactly how it transpires. There is no other way I would say we can get around this. Right, let's go to 3.2. They say that we should simplify, and we are given x plus 3 over x plus 3 over 4, and we want to simplify this. Now we know what our LCD would be. Our LCD would be x times 4, which is 4x. This into this goes once, this times that. This into this goes once, this times that. Multiply out 4x plus 12 plus x squared plus 3x. 4x plus 3x, 7x plus 12 plus x squared over 4x. And when we are here, remember we were just simplifying here, so it's your choice whether you would want to multiply out by this, meaning you can say 7x 4x, 12 4x, x squared 4x. It goes once, 7 over 4, 4 8 12. You can have your 3 over x plus x over 4. That would be the simplification. And then we can go to 3.3, where we are given 30 x3 y squared z 63 xy5 z3. And immediately in 3.3.1 they say determine the following from the algebraic terms, the prime factors of each term. This is not the first time we come across this question. It was asked in the first tutorial of our N1. You just say 30 equals shift and fact. You have 2 times 3 times 5. So this 2 times 3 times 5, you have your x3 y squared z. And then you go to this one. You just say 63 equal shift fact 3 squared times 7 x y5 z3. So that's exactly what we would find there, right? And then that is just 3.3.1. 3.3.2, they want the lowest common multiple, the LCM. Now remember, the LCM incorporates everything that appears on both. So you would check, you have 2 and it's not there, you will take it. You have 1 3 and 2 3s, you will take 2 of them. You have 5, how many? 3 of them. Is it 3? No, this is x3, this is just 5, right? You would take that 5, and there's also a number 7, you would take that 7 as well. So we took 2 3 5, we took 2 3 5 and 7. You have x. What is happening here? Oh, that is x3 from this. Sorry, yes, from that. So we took numbers, we are done with numbers. We took 2, 3 squared is the highest, we take it. And then we have 5 with exponent 1, and we have 7. Good. We are now left with the alphabets. So you have x3, you will take that. So in here it's x3, in that one is x1, you will take the highest. You have y2, you have y5, you will take the highest. You have z1 and z3, you will take the highest. So when you multiply this, whatever number that you get there, that will become your LCD together with this. 3.3.2 3.3.3, the highest common factor. Now remember, with highest common factors, you would look for a number that appears on both. So I have a 2, there's no 2, you will not take it. There's a 3, 2 of them, 1, you will take the one with the lowest exponent. You have a 7, it's not there, you will not take it. You have 5, it's not there, you will not take it. You have x3 and x1, you will take the lowest. y2, y5, you will take the lowest. z1, z3, you will take the lowest. So that is 3x y squared z as your highest common factor. Okay, so now let's go to question 4. In question 4, they say solve for x. 7 into x minus 3 equals 7 minus 2 into 3x plus 1. So we will multiply out 7x, 7, 14, 21, 7 minus 6x minus 2. We can take everything to the other side, or we can group the like terms. We can have 7x plus 6x, that is equals to 7 minus 2, it's 5, plus 21, and this would give you 13. This would give you 26, and then your x can be a possibility of 2. Highly possible. And then in 4.2, manipulate the given formula and make x the subject of the formula. So r minus sx equals t. We want to make x the subject of the formula. Take this to the other side. Very good. Divide by minus s, so that your x is this. Very good. Very good. Somebody might want to say the following here. Might want to say this is r minus t over s. You are still correct here. If you divide by negative, then this becomes positive. And then in 4.3, use the answer in question 4.2 and substitute the following values to calculate the value of x. So they say that r equals 15, t minus 5, and s equals 4. Now remember, we want to find the value of x here, and we said that x equals t minus r over minus s. We will just justify whether this is true by using that. Your t is minus 5, minus into your r is 15, minus, and your s is 4. So you would have minus 5 minus 15 all over minus 4. This is minus 20 divided by minus 4, 4, 8, 4, 8, 12, 16, 20. That would give you 5. Right, let's check with this. X equals r minus t over s. This would be 15 plus 5 all over 4. Can you see that we're getting the same thing here? 20 divided by 4, which is 5. So we were very correct to say those are exactly the same. Right. Let's go to question 4.4. The Earth travels 881,922,512 kilometers in 1 year to go around the Sun once, so to complete one full cycle. If there are 365 days in a year, which we can debate and argue about, that's fine, but we will not do that. At what speed does the Earth travel in kilometers per day? Now, they say 881,920,512 kilometers equals 365 days. Are we fine? Because they said the Earth travels this number in 1 year to go around the Sun, and we know that the year they said it's 365 days. If there are 365 days in a year, at what speed does the Earth travel in kilometers per day? So what is this? This is the distance. Okay. And there they are looking for the speed, and we know that speed equals distance divided by time. Right. The Earth travels 881,920,512 kilometers in 1 year to go around the Sun once. If there are 365 days in a year, at what speed does the Earth travels in kilometers per day? Now we are looking for time here, and it is not provided, but we know that 1 day equals 24 hours, because we are looking for time in terms of hours. We don't have 1 day, we have 365 days equals x. Your x is 24 times 365. That would give us the number of hours. So the number of hours would be 24 times 365, and that would give us 8760 hours in a year. Those are the number of hours in a year. So therefore I can say the distance, because I'm looking for speed, that would be 881,920,512 kilometers. I would divide this by the time required, 8760 hours. Let's see the speed in kilometers per hour. We can do this in minutes, we can do this in seconds, and so on. We just decided to do this in hours. Sorry, they said at what speed does the earth travels in kilometers per day. Oh, forgive me, I'm very sorry, I'm very sorry. So in kilometers per day, how many days are there? So you would have time will be in days. So speed equals distance over time, 881,920, 512 kilometers per day. How many days are there in a year? They have already told us 365 days. So this would be kilometers per day, time expressed in terms of days. I'm very sorry. Right, I would just say 881,920, 512 divided by 365. So that would give me the speed of 241,6220.581 kilometers per day. So the speed is 2,416,220.581 kilometers per day. This would be the speed. Okay, 241, let me see, yes, let me see, 241,6220. So meaning that would be 2467. So let's say 2,416,220. That would be the number, 0.581 kilometers per day. So it's 2,416,220. Yes, that would be the speed. And if the speed is directly proportional to the distance and inversely proportional to the time, which is expressed in terms of days, meaning if the distance is enormous, the speed is enormous if the time remains the same. So in here, this is the constant speed, and we might see this as very fast, but because of the distance that is provided and the number of days that are provided, this is the answer that we get. We don't have to go very deep into that. So in 4.2.2, if there are 365 days in a year, at what speed does the earth travel in kilometers per hour? Now can you now see the hours are now coming? If there are 365 days in a year, at what speed? Speed, distance over time. Right, the distance still remains the same as 881,920, 512 kilometers, but now in terms of hours, fortunately I had already done that, 8760 hours. And what answer will I find? So I can just say divide this by 8760, and that would give me an answer of 1,006,7 5.8575 kilometers per hour. This is what I would get. What is this number? What is this number? We have 1, 2, 3, 4, 5, 6 numbers. So it's 1,000. This is not a million, it's 1,000. So what is this number? This number 100675. Let's check. 1, 2, 3, 4, 5, 6. So you have 6 digits. 1, 2, 3, 4, 5, 6. So this digit for just here, I would say 100,000. Am I fine? This is 100,000. So what is this? 100,675.8575 kilometers per hour. 100,675.8575 kilometers per hour. Right, and then we go to 4.5, which is the end of question 4. And in 4.5 they say the sum of two consecutive numbers is 31. Find those two numbers. Now they are not very specific here as to say those numbers are odd numbers, even numbers, or whatever. So the sum of two consecutive numbers. So let's let the first number be x plus 0. I'm going to treat this as the sum of whole numbers, x plus 0 plus x plus 1, and I'm going to say this is equals to 31 because they are consecutive. The sum of two consecutive numbers, the first one is x, the second one is x plus 1, and find those two numbers. So that would be 2x plus 1 equals 31, and then x equals 30 divided by 2, which is 15. The first one is 15 and the second one is 16. Now I'm going to pause this in here and we will continue in part 2.